Hello, welcome to the video. So today's video is going to be an update for the Nash compiler. So in this video, mainly I'm going to be talking about nashlib, so the Nash assembler library, and I'm going to be doing a quick overview of what I've been working on recently with the actual compiler, and also what I've been working on with this. Okay, so let's get into it. So this is what I've been working on recently, just kind of finished. I've been implementing labels and data. So data is like, for example, I'll do a little bit of assembly here. If I did a label db and then some information like hello, that would be what it would kind of be like. So it would be more like this. So this is basically what data is. It's just some data and a label that points to it. So I'll explain a bit what it is. So this is the information. This is the size of the information. This is if it's local or global. This is kind of a bit low level. I may remove this later on or a bit different. So I don't know about this. This is a bit low level. I'll maybe explain it in later videos or something. And this is the name of the actual label. Okay, so let's continue. So this is where we actually make the data. So this is just a data object, and then we add the data. We create a label. It's a global label. And then we make an instruction, which is calling the print label. So this is down here. It's defined after the actual calling. So this is done by actually resolving the offset or address later on and then writing it into the temp.out file into the correct positioning. So we need to build that. Just build nashlib itself. Okay, let's go to the example. Let's build the example. And then run the example. So it hasn't got any output because it doesn't really need any, but then we get a file output.o, and as you can see, all the instructions from here defined here. I'll put the description, I'll put the GitHub link in the description so you can have a look at this if you want to check if it's all correct. So all the instructions here are generated, labels are defined. This instruction here is the actual instruction here. So as you can see, creating a label. So this is a label operand object. So it it references this message label, which is defined here in this data object. So this here will add the label to the labels list. And as you can see, it's set to 0. So how does that make sense? How do we move 0 into ECX and then it references message? Well, we don't. That's actually not really how it works. So the ELF format actually has this relocation table. So this relocation table, we define the offset of the here we go. Here, this is the offset of this here. So this here is, we're telling it that instruction, this code, not really code, this information here is pointing to a position in the data section. So this is 0 here is saying at the 0 offset, because it's like an array or like a string, at the 0 offset is where we want where our information is in the data section. Okay, so yeah. So that's what I've been working on, and let's see if we can actually compile our output. Well, not, I mean link our output. There we go, that's the instruction, well, I mean command I used to link it. And then we run it and it has hello, or says hello. So as you can see, that is the same as here. It even has the new line. So you can check that out if you're interested. Okay, so now let's take a look at the other thing I've been working on. Probably get rid of it, I'll keep it. Okay, so let's have a look. So this is the actual compiler. This is where the code is going to be, I don't know, lexed, and basically this is where the code is going to be converted from code, so like this. May change later on. I don't know if I like this syntax completely, so I don't know if this is going to change later on anyway. So yeah, so what's happening here is we're getting the name of the file here, then we read in the file's contents, then we pass it to the lexer. The lexer is this code here. So I'm actually following the crafting an interpreter tutorial. So I know that's for an interpreter, not a compiler, but I thought a lot of the concepts are basically the same. Like the lexer is going to be exactly the same for a compiler. Well, this is only, like, I've never actually written a programming language. Actually, I think, like, I would barely even call it a programming language. It wasn't a programming language, but I've never actually written a programming language in my life, so I don't know if I'm correct or not. I'll probably figure out later, and then, you know, it'll either work or fail, and I'm going to have to restart everything. But anyway, in what I think is they're basically the same. Alexa is Alexa, a parser is a parser. Like, the only difference will be like the interpreter will convert the AST to like it'll run it, but then a compiler will convert the AST to code, like an IR or like machine code in my case. Which later on I'm actually going to make it so Nash, instead of requiring you to put in assembly and, you know, generating all that, I don't know, functions and all that, I'm going to make it so as binary IR, so that all we have to do is supply an IR that then it will like LLVM IR, but in a binary format, so we don't have to handle like ABIs and architectures and all that. It does it all itself. So all we have to do is have one back end that converts our code, or AST, into a IR, and then Nash will just do it all for us. So we don't have to do all the hard work too much. Well, the compiler doesn't have to do too much work. So yeah, this is just basically a copy of the tutorial, but in C++, so I don't really take much credit for it. That tutorial is really good. I like it. It's, if you want to make a like compiler or anything, I would suggest reading up. It's really good. It explains everything. It's simple. It's in Java, so it's not actually hard to understand. So yeah, like I don't actually know much Java at all, but I still understand most of the code. Obviously, I can't do everything the same as in here. They've actually used an object type. An object type in Java is just the same as, well, it's any object, really, any object. Like integers, I'm pretty sure, also an object, anything, really. But since that's not actually possible in C++, I'm just going to do a string, and then maybe later I'll convert it to something, or like if it's an integer literal, I'll just convert that integer literal to a integer in the parser, and then the AST will hold the literal value or something like that instead of having an object, because I don't really want to have different tokens, because this is the actual token. I don't want to have like token for integers, and I don't want to have a token for all that. So but the AST will have that. It will have an AST node for integers and an AST node for strings. So I can have that different actual literal values in there. So yeah. So I'll actually run that just to show that it works. We can build it. And then we need to run it. Main.nash. As you can see, here's the name, here's the actual code. In the end, I won't actually print out the code. This is just to make sure everything's working. And here are all the tokens. So as you can see, this is a identifier. This is a identifier. This is also a, well, this is actually a string here. And this is an identifier. So all 121 are identifiers. And function here, yeah, here we go. Function, as you can see in the tokens, is 28. So it's not an identifier, because I define it as a keyword up here in this static or constant map. Also, this is a trick I learned. I had to go on Stack Overflow for. Where's my code? Identifier here. So if you do like keywords and then my string, like I don't know what, 4, if I look for this, normally if it, well, this is what happens. If this does not exist, it will create it. And since I defined it as a constant, I cannot actually change anything. So what you actually have to do is use the find keyword, and it will create an iterable, or an iterable type or whatever. Then what I do is check if that's end. If it is, which means that keyword doesn't exist, it's an identifier. But if it isn't, then the type is whatever the keyword defines, like and or else or false. So yeah, that's a cool thing I actually found out. It's pretty helpful. Because I once had that issue with Nash and I didn't actually know how to fix it, but guess it's possible. I don't actually use that way anymore, so I can't really use it anyway, but you know, it was good to know. Yeah, so I think that's all. Hopefully I haven't missed anything, and hopefully next week I'll have an update on Nash, like the Nash compiler, and yeah. So I think I'll just be working on the AST, the parser and all that. I won't actually be able to get anything significant like actual code running, or hopefully actually in a week I'll be able to. Doubt it, because I still have a lot to learn. But yeah, hopefully in a week I'll have an update on at least if I've got anything really. I like to have an update or updates because, well, I have two reasons really. One is because then you guys, or probably no one right now, but in the future people can have a look at what the project used to look like, and like have a look what I did and my processes of doing things and what I had to do to create a compiler, so other people can look at what they have to do and may have to learn and all that. Because I think making compilers is a really good experience. It really teaches you a lot about computers and operating systems. Like if you want to actually learn a lot about operating systems, do operating system development. But I've learned a lot about like instructions or machine code and all that, because previous to this I have never written a program language. I didn't know any machine code. The way I learned was actually someone helped me learn it. That was really helpful. Like, I don't think I would have ever been able to do this if they didn't help me, because I'm not very good at this stuff, really. A lot of this I don't even know like what I'm doing most of the time. I'm just doing it. Like, my code's probably really trash if people accept this, because I've actually been copying the tutorial, so this code's obviously good. But the actual like Nash lib, I would say its code is just trash. It works, but it's not good. Like, yeah. So obviously I'm gonna have to improve on it later. Gonna have to optimize it, make it better, obviously. So yeah. So if you really want to learn make a programming language, I would say go for it, because you don't need to know everything to make a programming language. You don't need to be great at well, I wouldn't say that. It is pretty hard, but you don't have to be like really good at it. Like, I'd say it's a really fun project, even if you're a beginner. I would say make an interpreted language if you're a beginner, because it's kind of easier. But if you've got the time and dedication, yeah, you should probably. It's really fun to make a actual compiler. And also, I'm doing this the long and like kind of the long and hard way, because there's like LLVM that you could use as a backend, and it'll basically generate optimized assembly, and you don't even need to know assembly for it. It'll do all that for you. And with like, if you wanted to generate gas, or like if you wanted to use, because there's Porth, which generates Intel syntax assembly and uses FASM now, because I'm pretty sure NASM wasn't actually fast enough. Or was it YASM? I can't remember. There's so many out there. But it generates assembly. So that's also another solution to it, where you don't actually have to write your own assembly. You use someone else's assembler or a backend like LLVM, which just speeds up the process. But I thought it'd be fun to write an assembler. And yeah, so this is where I've ended up at the moment, working on for a long time on annoying code, trying out annoying things. But you know, in the end, it's fun. It feels like you've accomplished a lot once it works, because it is a very big thing. So the bigger it is, the more you feel like you've accomplished. Well, now I'm just rambling on, like literally nothing to do with the video. So I'll just close down the video now. I'll end the video now. So yeah, if you enjoyed the video, like and subscribe. If you have any questions, put in the comments. If you have any suggestions, like feature suggestions, put that in the comments. And also, I've started a Discord server. It's like, I've got barely any people in it. So yeah, if you want to join the Discord server, I've got that in the link in the description. Also, I've got the crafting interpreters link in the description if you also want to learn that. I've got the Nash lib, and yeah, I'll just actually put the whole organization GitHub profile, whatever, in the description, because that has everything like Nash lib and Nash in it, so you can have a look at that. I'll put everything really that I've used so far for Nash in the description, because then you can have a look at it all. So yeah, thank you for watching. Hopefully you liked the video, and I hope I see you next video.